Hello everyone, you are welcome to my YouTube channel. In today's video, we will be looking into data analysis with Pandas. Here we'll talk about what Pandas is and then also look at how we handle data analysis, especially explorative data analysis using Pandas library. Pandas is a powerful Python library for data analysis and manipulation. It provides a variety of structures and functions for loading, cleaning, wrangling, and analyzing data. Some of the key features of Pandas for data analysis include the first is data structures. Pandas provides two main data structures for storing and manipulating data. One of them is the series, and the second is the data frames. The series are one-dimensional arrays with labeled indices, while data frames are two-dimensional tables with labeled rows and columns. The second key feature is data loading and cleaning. Pandas provides a variety of functions for loading data from different sources, including CSV, Excel, SQL databases, and even web APIs, that's application programming interfaces. Pandas also provide a variety of functions for cleaning data, such as handling missing values, or what we call NA, removing duplicates, and converting data types, moving from string data type to integers, from integers to floats, etc. The third feature is data manipulation. Pandas provides a variety of functions for manipulating data, such as filtering, sorting, grouping, and aggregating data. Pandas provides a variety of functions for performing common statistical operations such as the mean, the median, the mode, and standard deviation. The last feature I will talk about is data visualization. Pandas provides a variety of functions to visualize data, such as creating histogram, bar charts, and line charts. Pandas can also integrate well with other Python libraries for data visualization, and such libraries as Matplotlib, Seaborn, and Seaborn. So at this point, we'll go into demonstrating how to first of all set up the our respective required libraries, and also what now generate data and how to use uh, the pandas data frame, to manipulate those data, do data wrangling, do data cleaning, and also lastly we'll talk about the explorative data analysis. And then in part two, I will further use pandas to do more of reading and writing. Although in this video, we're still going to look at writing our data to output files, you know, after manipulating or working with that data using the Pandas library. So let's get started. We'll load our respective libraries. I will need the pandas library, so I import pandas as PD, import numpy as np. Then I need another package, random. I need random because here first I want to demonstrate how we can generate a data frame and then write them to a CSV file. So I will import these libraries. On the next cell, what I want to do here is that I have a group of characters, okay, of alphabet 26 in number. And what I want to simply do here is to generate a data frame that has names, okay, randomly generated names, and then randomly generated scores, and see how we can write that to the pandas data frame. And also after doing some manipulations, we can save the output data frame as a CSV file or as an XLS file. So next is for me to take, I need names. I want to randomly generate names. So I'll generate a list of names, apply my apostrophe and say join. I want to randomly generate names containing length of 5 strings. So, and picking each of those random strings from this Charles variable, which is character variable, okay, which is a string of 26 letters, A to Z. So I have join and I have then I'll call the random package and dot and sample random and sample method. Okay, and what do I want to sample from? I'll convert that character to a list. So I want to sample from the list of the variable character. Okay, what's the length of the characters I want to sample, which is k. I'll take it, I want 5. So yeah, then that is this. So 5, and I'll close this list. Okay, closing that, and then I want them converted to upper uppercase. Now that, if you see what I've just done there, simply generate a name, with random letters of length 5. But I want how many names do I want? I want it first the length of the variable charts. Okay, so I'll say 4. I'll now put in another loop here for underscore. I don't need the index. So in range of, I wanted the length of what? The length of that variable. And I'll close this out. Let's see what we have if I print names. You see, it gives me a list of what now? Of 26 names in this place. So I've done that. The next I want to do is to randomly generate scores. Okay, so there I will use the numpy library. So I use the np.random.rand integer, random integers. I want to generate scores between a lower bound. So my lower bound is 10 and my upper bound is 100. And what is the size of that array that I want to generate? I want the size to also be the length of cars. Okay, so that I'll have 26 names and 26 scores. Let's print the scores and see what we have as well. If we run this cell, you see we have already now the scores randomly generated. If you check the length of the scores, it gives you 26. So the next thing we'll do here is to generate a data frame. So I have data df, which is data frame, df. What I'll do is then to call, remember we have imported pandas as PD. Okay, so there are various ways of doing it. You can, generate it by from dictionary, but I prefer this method, data frame. And now I will pass in a dictionary. In that dictionary, I have a key, which is the names. And what are the names? You go names. And the next key in that point there is a scores. And what are the scores? You pass in the variable scores, the variable container scores. Now close that dictionary and then close my data frame. Right? At this point, let's print. Now in Pandas, we can print, if you don't want to view all the data frame, we can just print a head and specify the head. By head, if you run this, you see we have head 5. No, 5 items printed. So we have randomly names and score. Likewise, you don't want to just use head and you just print the data frame. What gives us, it gives us a data frame. You can see the length is 26 with randomly generated scores. The next thing I want to do here now is that for each of these scores, we want to generate the grades, the letter grades. Okay, so here we'll employ one method in Pandas, which is dot apply. But meanwhile, before we do that, there are two ways of looking up items in the Pandas data frame, which is dot lock and dot ilock. Okay, dot ilock work with uh, the indices as integers, while dot lock works with the the column names, the labels rather. Let me use that with the labels. Now let's do something here. I can decide to print df dot. We know one of the heading labels is course. What do we have? You see, it returns this course of that data frame, and right underneath tells you the name, the column name is what's course, and the type is what int 32. Right? It's an integer 32. Likewise, you can print df of names. This is one way you can print this to access. You see, it gives you all the name and tells you the object type. The type of that is what object, right? So this is what also we can do. So I will go back here. We have printed df.head and I'll leave it as .head and put it here. So to get letter grades, what do we do? Let me demonstrate the ilog before I move forward. Here we can do df.log, and I want to print the column name. If you don't want locating that, if we run this again, it gives me an error. Okay, location thing. I want all round and run this. Yes. So I want it given for all the columns. Okay, sorry, all the rows of the column scores. If you change this likewise to names, and then you can get all the rows of the column name. So this is using the lock. If you want to use ilock, then you have to use the indices, right? The first index of the data frame is zero. The next, so we have two columns, zero and one column. So here you have to use zero, and then you run it again. It gives us the names, because if you want to, if one is the second column, returns this course. So these are the various ways using the ilock and the lock to manipulate the uh, data frame. Next, now I will define, how to score my grades. So I'll write a function that says grade and takes in score. And what will it return? If the score is greater than 80 and less than or equal to 100, it should return an a lettered grade A. If the score is greater than or equal to 70 and less than 80, it should return letter grade B. L if the score is greater than or equal to 50 but less than 70, should return C. And anything less than 50 is an F. Okay, this is just my own grading system. It's not the universal grading system. So L if score less than 50, return F. So run this, we have a function already in the namespace. Now, what do we do here is that we want to see here we've started doing manipulation first. You notice that in our data frame, we only have two columns, names and scores. Now I want to create a third column, grade. That's why you see data df, and I pass in the name of that column, grade, that I want it, and equal to, what will I do now? To compute the grade, I need to look up this course, and then based on this function, allocate the letter grades. So what to do is to call df dot. Now I want to use the ilock. So the lock. If you use the ilock, then you have to use indices. But I use lock and I specify directly I want it all the rows, apply to all the rows of the column of scores. Okay, so look, pick up this data from me, okay, from the data frame, and then let's apply what? Apply this function to it. What it means is that for every of those item on the row, for every of those scores, apply this function. So it will check if the grade falls in within the range specified. It produces the exact grade, and then it does that and create a third column which is called grade in your DF. So if we run this cell, what do we have? You can see that already. That if I print DF, it has all my letter grade along line printed exactly to this point. Now here I have a none. Let's see why it returns none. Let's investigate that, because it should return. Okay, first of all, let me print the df, the data itself, the data frame, before applying the function. Or I think I know what is happening here. I will restart my kernel and run all the outputs one after the other. So let's run up to selected here and print df. Just restart the kernel and run up to. So this is what we have. Yeah, I know why it's happening that way because it's randomly generated. So each time we run this cell here, I randomly alter the scores. So this is that. Now I don't have to go back to this cell again. If I want to print this there, I have to take it out of this cell so that I don't alter because I have not fixed my random number. So to solve that problem, it's very simple. All we need to do is to do random so that we control the state of randomness. We do random.seed and then we choose any seeding value. I'll choose 23. And also I can control the np.random.seed and I'll choose 23. So right now, if we run this cell, each time you repeatedly run it, it returns the same output random numbers for the scores and the name. So next we'll check out our function grade. Our function grade is there already. So printing it, you can see it allocates all the grade, and then we have here. Then we run this cell now. So if we run this cell, the value of the none is gone because of that error we introduced by randomly generating the data. So having said that, we can see our data frame is fixed. There's something else we can do here. Now that we're finished, we have our data frame. Okay, so we can actually export this data frame and save this data frame. So how do we do that? We just call data frame underscore df dot to CSV. I always love saving CSV. You can export to Excel as well to CSV. And then you specify the file location. I'm working in this file location just outside this file in the file place known as data. So I'll move into data. There's a folder non-data in the parent folder. So data, and I'll choose the name. So I'll just put name should be student grades dot csv, and I'll close this. So if we run this cell, one more thing here. If you run this cell, you see this index is here, 0126 will be appended. So to remove that, I'll just put index and say index is false. You don't want it to include the index when it's saving the CSV. So run this cell, our CSV is exported, and then we have it in student grade. I hope maybe hopefully I can show you that in subsequent classes. But to be saved into this location you have specified here, and this location means I'm outside this subdirectory in the parent. I have another in the parent or root directory. I have another directory called data that takes care of this. So I've just shown here, for example, how we can generate a data frame. So you're working on something and then you want to export your values and save them. You can use Pandas. And I've shown you how we can do manipulation here. In the next example, I will show you how we can do data cleaning. Here we have just done data wrangling. I remember we have used the apply. There are so many functions that you can find very useful within the Pandas library. All you need to do is just to look them up. Okay, Google and look them up. The grouping, the group by. I cannot discuss all of them in this video as it will be too exhaustive to discuss them. Watch out for my next video, which is the second part and the continuation of the analysis of this data frame. Please like this video, share this video, and please subscribe to my channel if you have not done so. And remember to click the notification bell to get notified whenever I upload new videos. So until then, I will see you in my next video. Bye.